If you throw a loaded gun into a raging fire, what actually happens? I mean, Hollywood has trained us to believe it acts just like a ghostly hand pulling the trigger.
Right, like the gun just fires a bullet perfectly straight.
Exactly, with lethal precision right through the flames.
Hashtag.
But the actual physics of what emergency responders call a cook-off are much stranger and honestly a lot less predictable.
Yeah, and in many ways, significantly more dangerous.
Which is wild. And on a recent Thursday morning in Arkansas, a group of everyday commuters found that out the hard way.
They really did. They found themselves trapped in a scenario that essentially weaponized their morning commute.
It's terrifying. So, welcome to today's Deep Dive. If you're someone who loves to learn and unpack complex, real-world situations without feeling overwhelmed, you are in the right place.
Absolutely. Today we're taking a single, really intense audio news excerpt that details a severe collision near Jonesboro.
And our mission here is to examine the raw facts. We want to understand the mechanics of this disaster.
We're looking at how a localized, utterly routine traffic delay transformed, in literally a matter of seconds, into a highly volatile emergency.
Right, involving raging fires, secondary detonations, and, as we'll see, some extraordinary civilian heroism.
And we are going to look strictly at the facts reported in the source material. No speculation outside of that.
Exactly, because we just want to figure out how these specific variables collided. It's just human nature to be curious about how quickly the mundane turns dangerous.
It really is. And to understand the sheer scale of the chaos here, we first have to look at the incredibly ordinary circumstances that set the trap.
Okay, let's unpack this. Our source places this event on Highway 1 South in Harrisburg, Arkansas.
Right.
And the catalyst for the initial traffic halt wasn't some catastrophic event. It was just an ongoing paving project.
Yeah, right in front of a facility called Rice Tech Incorporated.
Which I think we've all been there.
Oh, for sure. And this is the perfect example of a vulnerable temporary traffic zone.
What do you mean by that exactly?
Well, in traffic engineering, a highway is designed for continuous high-speed flow. So when you introduce a stationary bottleneck like a paving project, you alter the fluid dynamics of that entire system.
Oh, wow. I never thought about it like fluid dynamics.
Yeah, you force a sudden, massive deceleration. The risk profile of that roadway just skyrockets.
Because everyone has to slam on their brakes.
Right, because the safety of the entire system now relies entirely on every single driver recognizing the visual cues. They have to process the change in flow and react in time.
It's that everyday friction of driving. You get those phantom traffic jams where you see the orange diamond signs and the brake lights ripple back through the line of cars like a wave.
Exactly. And everyone compresses into this tight, stationary pack.
But the report states that a commercial van, which was specifically identified as a FedEx delivery vehicle, it failed to stop for this halted traffic.
Yeah.
It ended up striking a white Ford pickup truck from behind.
Yeah.
And how does the predictable routine of a commercial route collide so violently with such a huge visual cue like halted traffic?
Well, it introduces a brutal transfer of momentum.
Yeah.
You know, commercial delivery vehicles, even just standard vans, they operate under very different physical constraints than your average passenger sedan.
They're a lot heavier.
Right, they carry significant mass. And when a vehicle with that much mass fails to decelerate, the kinetic energy involved doesn't just evaporate when the driver finally hits the brakes.
It has to go somewhere.
Exactly.
Yeah.
That energy is violently transferred into whatever's right in front of it.
And the vehicle in front of it was that white Ford pickup.
Which is just the worst possible position.
Yeah.
The vulnerability of a halted vehicle in a temporary work zone is absolute.
Because they can't move.
Right. The driver of that pickup was totally boxed in by the traffic ahead of them and the paving project itself. They were entirely stationary.
Making them a fixed target.
Unfortunately, yes. So the physical reality of the crash itself, the crumpling of the metal chassis, that sudden concussive force, it's just devastating.
But, you know, a rear-end collision, even a really bad one, usually just means deployed airbags, maybe some radiator fluid leaking onto the asphalt.
Yeah, typical crash stuff.
Right. It's a terrible insurance nightmare, but it's a linear, predictable event. The police arrive, they set up flares, everyone waits for a tow truck.
That is the expected outcome of a standard highway collision, for sure.
But this event immediately deviated from that baseline.
It did.
And here's where it gets really interesting. Because of a concept that is, frankly, terrifying when you really think about it. And that's invisible cargo.
Yes. Invisible cargo.
We treat the highway like a conveyor belt, right? Like a closed system where the only variables we need to worry about are speed and distance.
But it's actually an open system.
Exactly. It's highly vulnerable to whatever happens to be inside the boxes on that belt. I mean, think about your own experience on the road. You look at the vehicle directly in front of you and you just see the exterior shell.
Right, you have absolutely no idea what is packed inside the trunk or, under the tarp in a truck bed.
And what's fascinating here is that the specific nature of this invisible cargo instantly elevated this from a standard traffic accident to a severe disaster zone.
It did. The source details that the impact of the collision instantly triggered a massive fire. The FedEx delivery van rapidly erupted in flames.
Which, again, pushes back on our standard expectation of a car crash.
Yeah, because modern vehicles are heavily engineered to prevent post-crash fires.
Right. Gas tanks are shielded, fuel lines have shut off valves.
Exactly. So to have a rapid eruption in flames upon impact, it means the kinetic energy transfer was so severe that it likely sheared those protections entirely.
It just atomized highly combustible fluids right at the point of a mechanical spark.
Precisely. The initial fire was fierce, but it was what happened next that caused the situation to escalate with terrifying speed.
Because as both the van and the pickup truck burned on the roadway, eyewitnesses on the scene reported hearing secondary explosions.
Yeah. Over the sound of the roaring fire, they heard actual projectiles and detonations.
And the source tells us exactly what those detonations were. They were later attributed to ammunition and firearms that were being transported in the rear of the white Ford pickup truck.
This is that invisible cargo turning deadly.
The physics of the disaster shifted dramatically the moment that fire reached the truck bed.
It really did. The ammunition acted as a massive force multiplier. It turned a static emergency into a dynamic, highly lethal environment.
Okay, this is where I want to go back to that Hollywood scenario we talked about at the very beginning.
Oh, right, the gun on the fire.
Yeah, because when I hear live ammunition in a fire, my brain immediately jumps to a literal war zone. Wait, if the heat triggers the gunpowder, why doesn't the bullet just shoot out the front of the truck like a normal gunshot?
Well, because you're missing the most crucial component of a firearm, which is the barrel.
Oh, right.
To understand this, we have to break down the anatomy of a cartridge. Standard ammunition consists of a brass or steel casing, a primer at the base, chemical gunpowder packed inside, and the lead projectile, the bullet seated at the top.
Okay, makes sense.
When you fire a gun normally, the firing pin strikes the primer, and that ignites the gunpowder. The burning powder rapidly creates high-pressure gas.
And because that gas is trapped inside the steel chamber of the gun, it has nowhere to go but forward.
Right.
So it pushes the bullet out the barrel.
Exactly. The steel chamber contains the explosive energy and directs it. But in a fire, there is no chamber.
Right. It's just sitting there in the open.
Yeah. The ambient heat of the burning vehicles raises the temperature of the entire cartridge sitting in the truck bed. Eventually, that ambient heat causes the gunpowder inside the casing to auto-ignite.
This is what you called the cook-off.
Yes, the cook-off. But because the cartridge is not confined within a steel chamber, the gas pressure expands in all directions simultaneously.
And pressure always takes the path of least resistance.
You got it. The bullet is actually quite heavy, and it's securely crimped into place. The weakest point is actually the thin brass casing holding it all together.
So instead of the bullet flying forward at a lethal velocity,
the brass casing ruptures and shatters.
So it doesn't shoot a bullet, it turns into a localized fragmentation grenade.
Yes, unfortunately. The brass casing becomes high-velocity shrapnel flying in all directions. The bullet itself might be pushed out, but usually with very little force compared to a fired round.
Wow.
However, the hazard is immense because you have hundreds, possibly thousands, of these brass casings detonating and throwing jagged shrapnel outward.
That is terrifying.
It is. But, and this is a critical detail in the source material, there were both ammunition and firearms in the vehicle.
Oh, wow. Meaning some of that ammunition might have actually been loaded inside a gun?
Precisely. If a loaded firearm is subjected to that extreme heat and a round cooks off while inside the chamber of that actual gun sitting in the fire,
it does have a barrel to direct the pressure.
Yes. That specific round will fire with full lethal velocity, completely randomly, depending on wherever the barrel happens to be pointing as the vehicle melts and shifts.
That creates a catastrophic feedback loop. I mean, you don't just have a fire that needs to be put out. You have an environment that is actively generating shrapnel and lethal projectiles.
Right.
And the shrapnel punctures more vehicle components, which potentially releases more trapped fuel or oil.
Which feeds the fire.
Exactly, increasing the heat, which causes even more detonations. It perfectly explains why the fire was so immediately unapproachable.
Which is what makes the next phase of this event so remarkable.
Yeah, let's get into that.
Because with the highway now transformed into an active hazard zone, generating its own shrapnel, the focus shifts